We're looking this afternoon at how to inspire and enhance children's physics questions and investigations that you might do at any time of the year, but obviously we're focusing on the Great Science Share for Schools in June later this year. My name's Jane Banham. I am a Great Science Share champion. I teach part-time at a rural primary school in Lincolnshire, and we've taken part in the Great Science Share for Schools for the past couple of years now. Even last year when we were doing things virtually, I think actually the parents enjoyed it as much, if not more, than the children did, actually. They really got involved, and we had lots of dads doing things with the children and coming back and sending videos on Facebook to show us all at school. So we've been involved for the last couple of years. I'm also a STEM learning facilitator, so I'm hoping that sort of some of these ideas as well you'll be able to use for your STEM lessons as well as your science lessons across the year. Just in case we get any noise, I do live in a rural area, and I am living on a farm, so hopefully I won't get too much noise, background noise, but just in case I will sort of stop talking and we'll see how we get on. Just hopefully you all got the email with regards to please having a pen or pencil and piece of paper handy just alongside. It doesn't even matter if it's a piece of newspaper or scrap paper. We are going to use it part way through the session. Okay, so if it's not there with you now, just sort of grab a piece, whatever it might be. So for today, our overview of what we're going to look at is going to be, how do we need to ask questions? So why do we need to ask those questions? What do we do with it? And how do we encourage children to ask questions related to physics? And I think it's really important that we start to think about, why do we need to ask those questions? Not just for the Great Science Share, but actually also asking questions for the children in general, both us asking questions, but more importantly, the children actually asking their questions as well. And just before we go any further, can I just remind you all that this is being recorded. So if you don't want to appear on any of the recordings, please do turn your video off. And if need be, if you need to abbreviate your name, please do that as well. Okay. So one of the things that Great Science Share is really famous for and well renowned for is asking those questions. So obviously the Great Science Share for Schools is that fast growing campaign. It is about inspiring young people into science and the engineering aspects of it as well. And it's about communicating their own scientific questions and also those investigations that they might take part in with new audiences. I know one of the things that we've really promoted in my school is actually building that up through the year. So right from September, the children are aware that they're going to be taking part in the Great Science Share, and over the year they have that impetus of thinking about which is their favourite question that they've actually come up with and that they've then investigated, and all the time they're reviewing those questions and thinking about which one they're going to take forward and actually use in the Great Science Share in the June time. Now, we know that children are curious, and we know that questioning plays such a vital role in their learning. But we also know that children often need that bit of prompt and support in structuring those questions. And that's what I'm going to try and give you some ideas with tonight, with regards to what could we do? How could we prompt them? How can we actually structure some of that support without actually giving them the answers, without giving them the questions that they're going with, so they have the opportunity to actually develop and think up their own scientific questions? And if we look at the results and the numbers back from last year, I just thought it was interesting to look at this because I'm concentrating on physics tonight. And I thought it was really interesting to see that actually over a third of the topics that were shared last year were physics. So that's going to be really interesting to see actually how that develops, if that moves on. And I think one of the things that we really need to think about with regards to the physics aspect at the moment, before we go any further in this asking questions, is that problem with physics concepts. A lot of the physics concepts aren't visible. So the children don't necessarily see what that concept is. It's about developing it and how you are actually going to try and get the children to understand those concepts, understand that development, and understand that process and concept that we're looking at with physics. So just in the chat room, what I'd like you to do is, can you just type in there what your favourite physics topic area is? Okay, it might be even specific down to one area of that physics topic that you enjoy teaching. So just in the chat room, your favourite light. Great, thanks, Hayley. Gears. Oh, Helen. That's going for it. Gears, levers and pulleys. It's not very often people put gears, levers and pulleys. Often they try and stay away from that one. Magnets and sound. Circuits. Electricity. Forces, so forces in general. Oh, electricity looks to be coming out on top. Looks like most people enjoy teaching electricity the most. I have to say, just going back to Helen saying that she enjoys gears, levers and pulleys, I must admit it is one of my favourite areas as well. I really do enjoy teaching those areas. And I think this quote here from John Dewey is really important. What is in a question, you ask? And this really is obviously focusing at the teacher at this point in time, and we will cross across to actually getting the children to ask questions in a few minutes. Everything. It's evoking, it's stimulating a response. It is in essence the very core of teaching. And if you want to know some more about this quote and actually finding more about physics misconceptions linking to teachers asking questions, do listen to the podcast from Anne Harrod that's on the great Science Share website, because I know she's really concentrated on this and looking at the misconceptions in physics that obviously link into tonight's session as well. Now, as teachers, we're often really wanting to get those students to start to ask better questions, okay? It's every teacher's dream to actually get the children to really start to ask those really clear, really good scientific questions, because not only does it reveal their understanding of a topic, but it also starts to promote more curiosity. And it's about them actually taking ownership of their learning at the same time as well. We need those questions to promote that thinking, to actually give those opportunities for discussions, but also it's that key time as well for highlighting any misconceptions that might appear or any misconceptions they might have had. And I think it's something that we really need to be bearing in mind with regards to all the closures we've had in school and children learning things at home where maybe they've had the opportunity to actually take on board misconceptions, and maybe we've not had that time in school just yet to actually realise what those misconceptions are and start to try and discuss them with the children and hopefully move those misconceptions into correct conceptions about physics concepts. Also think it's really important at this time to actually just look at this. So this is from the Siri team from the Q Smart, and it's a definition for a science question. So that scientific question stimulates inquiry, okay, that curiosity, that inquiring mind, so that that evidence is gathered, those conclusions are drawn, and that knowledge develops. And I think it's really important that when we look at this as scientists, that actually this is much more, it's much wider, it's a bigger concept than actually just asking a question. The actual idea behind a scientific question is really about doing all of those other things as well. It's not just about asking a question, it's about thinking about the ways that you actually might go about trying to answer it. It's also about actually thinking about how you actually might gather that evidence together to answer that question. But it's also about that deeper scientific understanding as well, that deeper inquiry. It's about drawing those conclusions and actually starting to relate that knowledge and that practical into actually answering that scientific question that you'd asked as a child in the first place. So I think we need to be bearing in mind all of these things when we actually start to look at asking questions with the children. Just going to give you a minute just to read this one. And a bit of a quiz in the chat room. Anybody want to volunteer before I tell you? Which key stage do you think these 3 bullet points have come from? Okay, so imagine the bullet points 1, 2, and 3. Do you want to have a go at thinking about what key stage they are from? So their own questions about what they notice. Where do you think that's come from? Lower key stage 1, lower key stage 2, or upper key stage 2? Have a go, just give me a guess in the chat room. Key stage 1. Super, everybody's going for it. There we go. So we've got key stage 1 there. So yeah, being able to ask their own questions about what they notice is from key stage 1. Okay, giving the game away a bit here. What do you think the second one is? Their own questions about what they observe. Where do you think that's from? Yep, lower key stage 2. Got key stage 1. I've got key stage 1. Key stage 1. Key stage 1. Okay, so we've actually got there in that list there, we've actually got that progression. We've got that progression in asking questions. So pupils are needing to understand scientific ideas, and it's about them asking their own questions about what they notice, what they observe, and then actually linking their questions back to scientific phenomena. And just bear in mind that we are asked, if you're at key stage, end of key stage 1, so if you're a year 2 teacher or you're a year 6 teacher, when you do your teacher assessment statements at the end of key stage 1, at the end of key stage 2, this is one of those things that you have to make sure that you're aware of. So can the children ask their own questions? And it's something that we must all value, those questions that the children create. And at this stage, we're really wanting them to understand that asking questions is fantastic. There are no wrong questions to ask, but it's about them becoming more practiced and then beginning to be able to actually review and improve those questions as they develop. So really starting to think through, what questions are the children coming up with? Where are they with their questioning? Can they clearly phrase a question? Do we give them the opportunities for asking those questions? Are they at the stage where they can actually phrase the question and they're starting to get to the idea where they're going, oh, well, actually, I quite like that question, but I think I need to phrase it slightly differently. So starting to think about giving them the opportunity to review and improve their questioning as well. And I'm just going to let you go into chat rooms in a moment, because what I'm going to ask you to do, you're going to go into breakout rooms, is when you're starting to think about asking questions, do you in the classroom, and if you're on here as a subject leader, do the other classes in your school, do the children have that chance to ask their own questions related to the science that they're doing? How much independence do those children actually have? Okay. And not only do they have that opportunity to ask their own questions, do they actually also have that opportunity to ask and then have a go at answering their own questions as well? Okay, so you're going to go into a breakout room. It's just past 4:15 at the moment, so I'll give you till just after 20 past. So I'll just have sort of 5 or 6 minutes in your breakout rooms to talk about these 2 questions. So do the children have the chance to ask their own questions, and how much independence do the children have? Okay. Off you go into your breakout rooms. Then, so I just dropped into some of your rooms, and what was really interesting to see was that quite a few of you have got that questioning going on. And where that questioning is taking place, sometimes it's actually trying to get the children to phrase questions properly and trying to get them to use the correct scientific vocab when you're actually asking them to create the questions. And what I'm hoping that we get out of today is that this will just give you a little bit of a structure, a little bit of almost a format which will allow the children to ask their questions, whilst at the same time actually giving the children that opportunity to have the freedom of asking questions, but while you at the same time are giving them a little bit of a structure, a little bit of a format to work with. The room I was in, we were chatting about one of the resources that one of the schools was using, which I think by the sound of things was the one that the Association of Science Education and the Geography Association put together, which is a bit of a grid format. And hopefully some of the ones that we're going to show you now from the Great Science Share website will really help you structure those as well. We're going to move on. So I just really wanted to share with you some of the resources that you can actually access. Obviously, some of the resources on here are quite varied, but the one we're going to focus on today is that question makers. Yes, so somebody's just put in with regards to Explorify. Explorify, yes. Wellcome Trust, free to access, has got some great ideas in there, and some of you actually might use some of those problem solvers or some of those mission survive type activities out of Explorify for your actual Great Science Share investigation days, as well as actually using it for creating some of the questions from the maybe the what ifs or the big questions that are on Explorify. Thank you for that. I think that was, I know it says Thomas C, but I think it was from Charlotte from memory. So we're going to focus really on the question makers and how we can use that to develop questions with the children. We're not going to use all of these today, but I just wanted to make you aware of the question makers that are available on the Great Science Share website. So we're going to focus on a few of these, but as you can see, there's quite a range of different ones that you can use. And I have to be perfectly honest and say, I do have my favourites in amongst these. And that might have slightly influenced what I'm going to do with you and the ones I'm going to share with you today. So I'd like to set us off by actually just looking at this one. So as you can see, I've chosen the topic of light in here. I know it wasn't, in fact, folks, I've not even chosen electricity for any of my topics today. I've put other ones in. So I'd like to look at this one. So this is one of the examples of question frames. And what I'd like you to do is to look at that image, and in the chat room, can you put in the chat room any questions that you're actually starting to now ask yourself, but also questions that you think the children might come up with when they look at this image? And it took me ages to find this image, and I'm just interested to know if anybody's going to come up with some of the questions and the reason that I really sought out this particular image that I was after. So in the chat room, any questions that you've got that you're asking yourself when you look at this image? Now, I can't rotate it around here, but obviously in the classroom, you could actually rotate it around so you were looking at it from different angles as well. Yeah, why is some of it missing? Why does some of it appear to be missing in there? Different shades. Thank you, Haley. That's what I was trying to actually try and find something that actually gave you different shades of shadow in there as well. What is actually affecting it? Yeah, that's, why is there a triangle of light in the bottom? Can the shadow be different colours? What's making that thin shadow? What's that triangle of light that's appearing there? So quite a range of questions that actually might come from this shadow. And what I was hoping to create with this shadow in particular was, if you look at the image, you can see that the person's actually wearing a partially complete dress, but also one that's actually got patterns in it, but also bits in it that are actually translucent as well. And actually you can see the slight difference there in the shadows, in the shading, but also in that lighter triangle that's coming up from the corner. And sometimes it's actually about using some of these images to help you create those questions and starting to get the children to think about what concepts do they already understand, what do they already know about shadows. I have put the link on the bottom left-hand corner of this so that you can find it and use it, because it did take some trying to find a shadow that had actually got different shadings and got light coming in from different angles so that the shadow actually changed. Now, one of the other question ones we can use. Yeah, Christian, where is she going? So one of the other ones that we could look at is this question spinner. Now, this has got a lot of question stem starters on there, and it might be that if you were doing it with lower key stage 2 or key stage 1, you actually might have bigger sections with fewer question stem starters in there, so that the children aren't having that range of different question stem starters for every single time that they spin it, that they get used to actually asking questions that have got a particular question stem starter on there. And also starting to think about what sort of questions, and if you have goes at this, you'll experience how this works. If you've got lots of why and who's on there, the questions tends to come up very much with more research-based type questions. So why was this invented? Who created this? Who first discovered this? Who found this out? Whereas if you've got some of the other question stem starters in there, you get a wider range of inquiry investigation types that you can actually have a go at answering those questions, rather than having more research-based questions that the children are starting to create. And then there are ones like this. I wonder how. I wonder what happens when. And again, these are those that can actually create a wide range of questions, and again, give you the opportunity to actually look at a variety of different inquiry and method types. And I just want you to have just maybe 2 or 3 minutes in a breakout room now. And I just want you to reflect on, when was the last time you actually let your children ask and then investigate their own questions? Do you actually plan those opportunities for the children to ask questions? And what strategies do you already use to help you with that? Okay, so only just literally 2 minutes to do this, because I want you to actually do an activity in the next few minutes. So 2 minutes just to reflect on when was the last time you did it with your children, and what opportunities do you actually plan in for those children to do that? Okay, so Steph's going to put you in your breakout rooms literally just for 2 minutes, please, folks. Oh, fantastic, Mrs. Hodges. Okay, so we've just had a few minutes sort of reflecting on that. I was going to do a little section to see if you could actually put your top tips up, but I'm just very aware of time. But if you do have time as I'm going through the next section, and you've got some top tips for how you've gone about it, what you've used, that would be great if you could put them in the chat room. We'd really appreciate that. And obviously we can save the chat for you to actually access that as well. Now, obviously, we're trying to encourage the children's questions, but we're also trying at the same time to encourage questions that can be investigated in different ways. And I think it's important that we do think about those question stems that we're using, so that we can also make sure that those question stems open up those questions, so we can actually have a look at the different inquiry types. And there's the inquiry type images that you can access on the CSSfS website there. So I mentioned before with regards to these question stems and how they produce the questions for different types of inquiry. And it's about creating our own questions from the question stems here, but also making sure that we actually include that vocab as well. So I'm just going to really quickly, I only want you to use those 3 question stems, and I want you to use this vocab. Can you really quickly just come up with a couple of questions that only use those question stems and only that vocab. So some of the vocab there from the year 5 forces topic. So have a go. What, where, and is. Can you think about what questions you could come up with only using those question stems, using that vocab? And it might be that you come up with these sorts of questions. So what are newtons? What does air resistance mean? Where does the word force come from? And as you can see, if you look at those sorts of questions really are limiting. What is the opposite of friction? Yeah, those questions are really limiting the sort of inquiry types that you could actually have a go at investigating with the children. So it's about trying to open that up a little bit more and thinking more about the question stem choice that you're using to actually go with the vocab. So one of them could be, and again, this is on the Great Science Share website, one of them could be a question hand. And this is where it comes to you with your little piece of paper and your pencil. Because what I'd like you to do is, can you draw around your hand twice? Doesn't have to be neat, just as quickly as you can. And on one hand, on the fingers, I just want you to choose a question stem to write on each of those fingers. So on one hand, I just want you to choose a question stem and write on one of those fingers one of those question stems. I've put 7 there. You only need to choose 5 of them, obviously, and you should have got one hand that's got nothing on it whatsoever. I'm going to carry on talking because hopefully you can do that as I chat through the next section. And then I think it's really important that we start to think about what vocab are we using? So what vocab are we using with those children to actually make sure that the vocab's progressive and that we're making sure the children are familiar and literally embedding all the time the science vocab that they are using? Are we actually using progressive vocab? Are we using the right vocab for the year group that we're teaching, for the programs of study we're teaching, and for the topic area we're teaching? And the ones here I've just pulled straight off the Plan Assessment website with regards to year 3 and then the year 6 with the added year 6 in bold there for you. And it's making sure that we're actually using that vocab with the children and we're using it correctly. So what I'd like you to do is, on your other hand, okay, I want you to think about what vocab you're going to use. So you can either use some of the light vocab or you can use some of the forces vocab that I've put in here. So here's the progressive vocab for those ideas behind forces. So even down in year 1, I know lots of people sort of think, well, we don't do physics at all in Key Stage 1, it's all biology and chemistry, but there is that physics aspect down there with regards to seasonal change. And if the children aren't understanding that, it will make things more difficult as they go up through school if they don't understand that, because we tie quite a lot of that into the light aspects as well. So you should by now have got one hand that's got your question stem starters on and one hand that's got subject-specific vocabulary on it. Just give you a minute just to finish that off. So I don't need this in the chat room, but what I'd like you to do is actually just try, and if you can imagine, you've got your fingers with your question stems on here and your fingers here with your vocab on, just have a go at interlinking them like that and see what questions emerge. So you might have got what if and light on here that link together. What question can you come up with? And then look at the next link. And if those questions really don't appeal to you, literally just move them on. So move the one hand on further so that actually they link in different places. So I'll just give you a minute or so to do that. I'm just very conscious of time, so let's just keep cracking on. And think about the questions that you've just come up with. So that vocab that we've just used there might be for general questioning right at the start, almost potentially as an initial assessment opportunity to see if the children are familiar with the vocab, what sort of questions they come up with. You might even link those things into things like a KWL grid right at the start of the project, right at the start of that science unit that you're looking at. But then it might be that further on, you actually change the focus slightly. So again here, and this is actually an example from a year 3 lesson that I did recently, is if you imagine you've got your question stem starters on one hand, and on the other hand, put each of these different objects, so put an object, so you've got length on one, you've got size of paperclip maybe on the other, on another one you've maybe got thickness of material, and on the others you might have got maybe different magnet types or strength of magnet or size of magnet and those sorts of things. Now look at the questions that you're creating this time round. So the questions that you're creating from this one with your two hands, so you've got your question stem, and on this one you've got these objects on your other hand. What are those questions like that the children are now coming up with? Those questions they're probably coming up with now is starting to think about those different inquiry types, because you're coming up now with a lot more comparative, fair testing, grouping and classifying type questions than you might have been coming up with when you were doing it with just pure vocabulary from the vocabularies that we need to learn. So actually starting to think about those different ways that you could use those question stems, both for the hands or the spinners, or maybe those I wonder why ones. I was just looking at the, Charlotte's just put one in with regards to using science through stories and getting the children to ask the questions related to the stories and actually applying that understanding that links to those stories as well. Now, not only have we actually got all of these practical, so we've got some opportunities for assessment, we've got some opportunities for actually the questions instantly going into some practical investigations that the children can do. But we've also got lots of other things out there that actually will support us with this. So just a little bit there with regards to examples that are out there that we can use to actually support us getting the children to ask questions related to physics. Obviously, the STEM ambassadors, interviewing some of those with regards to how physics is used in their jobs, etc. And obviously they're all free. Ogden Trust have got some great physics questions on their website. Whistle Stop Science from PSTT have got some great ones in there connected with physics with regards to the paper one, the music and the space ones that are on there. And obviously the Institute of Physics have also got some great ideas on there as well. Oops. Just a quick reminder there with regards to the links of how you can actually sign up to take part in the Great Science Share. And also just a quick reminder with regards to being able to contact your local Great Science Share for Schools help with the regional champions. You can see where we're all situated. But finally, just getting you to start to think about actually how can you actually take this further when you go back into the classroom, when you go back into school, and maybe if you're on here as subject lead, actually how you might develop this back in school. That thought about actually creating more resources using those question strategies, and you might, like me, have your favourite ones that you prefer, but also getting people in different year groups to actually start using those science question strategy sets as well. And maybe even researching some of the websites to access suitable images to actually put in those frames and having that maybe as a starting point on your science display walls so the children can just go and look at that and ask the questions, but also starting to think about taking those question frame strategy ones outside with you and actually looking at some of the maybe the gears, levers and pulleys on the school gates or whatever it might be, and actually using those frames to help you support those questions. I hope that's been helpful in just giving you a few, maybe some heads up or a few top tips with regards to how you can actually get the children starting to think about how to create, how to develop their questions in physics.